Welcome everyone. We are discussing permutation and combination. So today I will solve some miscellaneous problem of permutation and combination. So I have completed the theory part. So these are problem of competitive exam. Look, problem number 1 and 2, they are of same type. How many different number of 4 digits each without repetition of digits can be formed with the digits 0, 1, 2, 3, 4, 5, 6, so that digits in each number in descending order, in ascending order. Descending order are number 2, ascending order. So descending order, greater to smaller, descending 9, 8, 7, 6 in this. This is descending, greatest number at the beginning. Descending order. Try to recall. And ascending order, smaller to greater. For example, 0, 1, 2 in this form. This will be the. So out of 7 digits, you have to take 4. So you are not using all. So you have to select first, then arrange. So out of 7, look, for 1, out of 7 digits, 7 digits. So they are of 4 digit number. 4 digit can be selected in 7C4 ways. 7C4 ways. Look, 4 digits, and this is in descending order. So you cannot take 0 at the beginning. 0 at the beginning. 0 at the beginning. So out of 7, you can select 4 in 7C4 ways. Then you have to arrange. The numbers. Now since it is descending or ascending order, so look, if it is of the form, so suppose you take one form. Suppose this is 6, 5, 4, 3. Or you can write 6, 5, 4, 2. So look, if you arrange it, you are getting only one case because it is of ascending order. You are not getting, if you use these 4 numbers, then we are not getting any number other than this one because it is ascending order. This one greater than this one greater than this, and this one greater than this. So out of 7 digits, 4 digits can be selected in 7C4 ways. And therefore, arrangement is only 1. So therefore, number of 4 digit numbers in descending order equals to 7C4 into 1. So 7C4. So 7C4, you calculate say factorial 7, factorial 4, factorial 3. So 7 into 6 into 5 by factorial 3 equals to 35. Equals to 35. So this is for case 1. Now case 2, ascending order. Ascending. You look. Ascending order. So in case of ascending order, since 0 is occurring, 0, 1, 2, 3, 4, 5, 6, 7 letters. So you have to select first. So out of 4 digits, out of 7 digits, 4 places can be selected in, or 7 digit you can say can be selected in 7C4 OH. So it is descending order. Descending order. So you can take also 0 as the first place. So suppose 0, 1, 2, 3. Then 1, 2, 3, 4. 0, 2, 3, 4. 0, 2, 3, 5. So you can take in this way also. Then 1, 2, 3, 4. But look, if number starting with 0, this is not of 4-digit number. This is not of 4-digit number. So total number without any restriction is 7C4. But if 0 occupies the first place, they are not of 4 significant digit number. So number having 0 at unit place. So how many remaining number? If you take 0 at first place, so how many remaining number? 6. And remaining gaps is 3. So 7C4 minus 6C3. 7C4 minus 6C3. 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 So 6C3 is factorial 6, factorial 3, factorial 3. So this is 15. So this is 7C4. I have already calculated 35 minus 16 equals to 15. Now look it again. If numbers are in ascending order, then you can take 0 is at first place also. But if you take 0 is at first place, then they are not of 4-digit number. So total selection is 7C4 minus number of selection in which 0 occupies first place. So if 0 occupies first place, remaining number is 6 and remaining place is 3. So 63. So for ascending, for case 2, out of 7 digits, 4. So look, this one, number 2, number of selection of 4-digit number in ascending order equals to 7C4 minus 63. So 35 minus 15 equals to 16. So I have already given the reason. Now what is the number of arrangements? It is ascending or descending. You look from smaller to greater, 0, 1, 2, 3. Only one arrangement is possible. Here also only one arrangement is possible. So number of arrangements for 4-digit number in ascending order equals to number of selections. So 74 minus 63 and number of arrangement is 1. So this is 16. So this is 16. We are getting total arrangements equals to 16. So now problem number 2. You can easily solve it. Look, this is of same. B1, B2, B3, B4. B1 greater than B2, greater than B3, greater than B4. So this is in descending order. 4 digits number. So here number of not given. So numbers are, if it is not given, so digits are 0, 1, 2, 3, or 9. So total digit 10. So it is not mentioned. In this case, we take total digit this. So therefore, 4-digit number. 4-digit numbers equals to. So look, it is in descending order. So out of 10, you can take 4. 0 cannot be taken in first place. So 4, 1, 2, 3, 4. So 10 C4 and number of elements equals to 1. We have already stated 10 C4. You calculate 10 C4. So factorial 10, factorial 6, factorial 4. So 10, 9, 8, 7, 4, 3, 2, 1. So 4 into 2 is 8. 4 into 2 is 8. This is 3. So 210. So 210 is possible answer. So they are of same type. Now we consider one more problem. Find the total number of ways in which 6 positive signs and 4 negative signs can be arranged in a row or line so that no 2 negative signs occur together. So 6 positive signs and they look like. So suppose we are writing this, then this is not. They are of same set, we suppose. Similarly for negative sign. So we have already solved this type of problem in case of permutation. So write 6 positive signs. We have already stated. Greater one you have to arrange first. So 6 positive signs. 6 positive signs can be arranged in a row in factorial 6 by factorial 6 equals to 1 range. So look, there is no distinction. 1 OH. Now how many gaps? 1, 2, 3, 4, 5, 6, 7. 7 gaps. So in 7 gaps, if we place 4 negative sign, then no two negative sign are together. So this is our condition. Look, positive sign may be together, no harm. No two negative sign are together. So if we place 4 negative sign in 7 gaps, then no two negative sign are together. This can be done in 73 into 1 by factorial 4 ways. 7 P3 out of 7, 74 into 1 by factorial 4 ways, because 4 negative signs are alike. So this one is factorial 7 by factorial 3 into 1 by factorial 4. So this one is 7, 6, 5. 7, 6, 5, and this is 3 into 2, so 35. So total arrangement by FPC, total arrangements by FPC. So 1 into 35 equals to 35. So using idea of permutation. Now you can solve it by using idea of combinations. 6 positive sign can be arranged in a row in 6 is 6 ways, 6 is 6 ways, 6 is 6 ways. They are same. So 6 is 6 equals to 1. Now if we place 4 negative sign in 7 gaps, then no two negative sign are together. This can be done. So negative signs are alike. So that is why we can write it 7C4 ways equals to factorial 7 by factorial 3 into this. So total arrangements equals to 1 into 35. So if they are alike, then you can solve it by using idea of combination. For examples, find the total number of ways in which 6 identical red balls and 4 identical green balls can be arranged in a line so that no two green balls are together. So this type of problem. Very simple one. Next problem. Find number of students to be selected at a time from a group of 14 students so that number of selection is greatest. Also find greatest number of selections when there are 15 students. When there are 15 students. So look at the theory first. It is not done. Look at the theory. It is a result of binomial theorem. So what is the result? NCR is greatest when R equals to n by 2 if n is even. N is even. And NCR is greatest when r equals to n minus 1 by 2 or n plus 1 by 2 if n is odd. So this is our theory. You have to remember. Greatest value of NCR. NCR is greatest when r equals to n by 2. N is even. And when n is odd, there are two possibilities. Now look, n equals to 14. N equals to 14. So this is even. So NCR is greatest when r equals to n by 2. So 14 by 2 equals to 7. So what is greatest value? Greatest value is 14C7. So 14C7 is answer for the first case. So you need only theory. Next case 2. N equals to 15. This is odd. Therefore NCR is greatest when r equals to 15 minus 1 by 2 or 15 plus 1 by 2. So r equals to 7 or 8. R equals to 7 or 8. 15 minus 1 by 2, 7. So greatest value. What is the greatest value? Equals to 15C7 or 15C8. You know they are same by complementary combination theorem. So answer for the second case is 15C7 or 15C8. They have same value. So simple problem, but you need this theory. So most important problem and simple also. Now we consider two more problems. Problem number 5 and 6. So, out of 14 articles, 10 are same type and each of remaining 4 are different. So, alike and this is different. Alike 10 and this is 4. Now, you have to select 4. Selection, this is problem of combination. Select 10 at a time. So, you can take 10, this is 0. This is 9, this is 1. This is 8, this is 2. 7, 3. 8, 4. 9, 5. So 5 is not possible. So these are the possible selections. Now you know, if out of 10, so they are all alike. They are all alike. So alike. So in each case, selection is 1. Out of 10, you can take 10, 1 at a time. You get 1 possible ways. Out of 10 alike, you can take 9. So this is also 1. And for different, it is 4C0. This is 4C1. This is 4C2. This is 4C3. This is 4C4. Because all are alike. In alike cases, if you take 1, 2, 3, each, since they are alike, you are getting only 1. So number of selections. So these to be noted. For alike cases, selection is 1, and for different, force is 0. So this one is also 1 because they are alike. So all are alike. 1 into 4C1, 1 into 4C2, 1 into 4C3 plus 1 into 4C4. So 4C0, 4C1, 4C2, 4C3, 4C4. And this is well known result. It is 2 to the power n. That is 2 to the power 4. So you are getting 16 cases. So remember it. These are alike. You can take LC9, LC8. Alike case you are getting in each cases only one selection. These are alike. For different, you know the formula NCR. So 4C0, 4C1, 4C2 and so on. So this is problem number 16. Sorry, 6. Then problem number 5. How many 4-digit number can be formed from 1, 1, 2, 2, 3, 3, 4, 5? So 4, 6, 7, 8. Out of 8, you have to select 4. Then you have to arrange because forming number is arrangement. So it is mixed problem of permutation and combination. We have already solved this type of problem earlier. So look, 2, 1. So 3, how many, what are the type of number? 3 alike set of 3 alike set. 3 alike set. So 1, 1 or 2, 2 or 3, 3. So you have to take 4. 3 alike sets. 2, 1, 2, 2, 2, 3. So 3 alike sets. 4, 5 are different. So you have to select first. So we can select 4. We can select 4 out of 8 by the following ways. Number 1. 2 alike set out of 3. Number 2. 1 alike set out of 3 and 2 different. And number 3, all are different. So these are the cases. We have already solved this type of problem. Find number of selection taking 4 letters from the word examination, Moradabad. This type of problem. So look, in this case, for the first case, number of 4-digit number. It was to first selection. Out of 3 alikes, 2 can be selected in 3C2 ways. This is number of selection. Out of 3 alike set, you have to take 2. So this is our selection. Then number of arrangements. Total letter 4. So factorial 4 by factorial 2 into factorial 2. Either these 2 or these 2. So 3C2 is 3 and this is 24 by 4. So 3 into 6. 3 into 6 equals to 18. For the first case, we are getting 18 possible cases. For the second case, 4-digit numbers. So selection, one allied set out of 3. So 3C1 and 2 different. How many different? You are taking one set. So 2, 3, 4, 5. 4 different. You do not think that there are 4 and 5, 2 different. But here we have taken only one set, either 1 or 2 or 3. If we take 1 set, then 1, 2 we can take, 1, 3 we can take, 1, 4, 1, 5. So this is 4C2. Out of 4, you have to take 2. And what is the selection? Factorial 4 by factorial 2, because 2 allied set. So 3 into 6. 4C2 is 6 and this is 12. So 18 into this is 36 into 6. 216. 216. And number 3, all are different. So 4-digit number. So 4, 1, 2, 3, 4, 5. 5 numbers. So out of 5 you have to select 4 into factorial 5. Factorial 4, not factorial 5, this is factorial 4. So 5C4 is 5 into 24. So 1 to 0. So these are the possible cases. So total numbers. So total numbers 18 plus 216 plus 120. So 6, 8, 14, 2, 3, 5 and 1 plus 2, 3. So 354. 354. So this is also most important problem. Now finally, how many arrangements can be made with the letters of the word Venus such that order of vowels remains unaltered? Arrangements can be made with the letters of the word. All the letters are to be used. So it is only case of permutation, not selection, because out of 5 you have to use 5. Now vowels remain unaltered. Order of vowels. So look, E and U are vowels. They are vowels. So 5 position. 5 caps. So what is the order of vowels? First E, then U. It is to be noted. Order. First U comes, first E comes, then U. So this is called order. So not in second and fourth position. Order is first E, then U. So look, if we take E at first place, then look, U can be taken in 4 places. In how many ways? 4p 1 ways. U can be taken in 1, 2, 3, 4. 4 places and 1, that is 4p1. So U can be taken in 4p1 ways. And remaining 3 places can be filled by 3 consonants in factorial 3 ways. This is case 1. Now case 2, if E is at second position, U cannot be here. So position of U out of 3 places, 3p1 and 3p1, and consonants can take anywhere. So this is in factorial 3. Now case 3, E in third places. So out of 2, u can be taken in 2p1. So this is factorial 3. Number 4, this is e. Then this one is u. So 1p1 into factorial 3. So if e is here, u may be here, but it is not the case. So you are getting 4 cases. So number of arrangements equals to factorial 3 into 4p1 plus 3p1 plus 2p1 plus 1p1. So this is 6. 4p1 is 4. 3p1 is 3. 2p1 is 2. This is 1. So 60. 60 is answer. So possible OH is 60. So E first, then E. So order of vowels. Now there is a shortcut method. If it is given that vowels, position of vowels remains unaltered, then we consider E and U. We consider vowels as same, that is alike letters. So out of 5, 2 are alike because E and E we have considered this as alike. So number of arrangements is factorial 5 by factorial 2. We consider these 2 as alike. So what is the case? 60 cases. So this one is shortcut method. If it is stated that not relative position, only so that order of vowels remains unaltered. In this case, we consider these 2 vowels as allied letters. Allied letters, suppose 2 are E. So factorial 5 by factorial 2. So this is shortcut. So today, through this video, I have solved some important problem of competitive exam of different type. So you know the theory, try to solve the problem of competitive exam. Thank you for today.